If you look at a project plan with every role filled and every milestone mapped, you might think you have a fully resourced schedule. But most of those schedules are already broken before the first task even begins. The root cause usually traces back to a single ordering error. Project managers build the timeline first, and then go looking for the people to fill it. It's highly common to blame delays on scope creep or poor duration estimates, but forcing an ideal sequence onto a team before understanding their actual constraints quietly wrecks more technical schedules than anything else. To manage staffing, most planners rely on a standard resource calendar, a grid of green blocks for free time and red blocks for booked time. But a calendar only measures physical presence. It tells you who isn't currently sitting in a meeting. It tells you absolutely nothing about a worker's true capability. The calendar hides their skill depth, their execution speed, and the cognitive load they are already carrying from support rotations and context switching. When you build a project schedule purely on job titles and this illusion of calendar availability, you haven't built a deterministic plan. You've built a wish list with due dates. The consequences of this illusion show up in the data. 62% of schedule slippage on multi-skill projects is caused directly by a mismatch between the resource assigned and the actual skill required. Despite that high failure rate, only 1 in 5 project managers build their schedules using actual skill proficiency data instead of generic role titles. This chart shows exactly where the breakdown happens. On the left is the standard task-first schedule. Notice how 4 out of the 5 tasks fail, marked here with red crosses. This approach assigns work to whichever calendar slot looks free, relying entirely on generic job titles, ignoring the specific technical demands of the work. Now compare that to the skill-first schedule on the right. Here, nominal capacity is mapped directly to verified skill proficiency, resulting in a solid wall of green checkmarks. Every single task in this model is assigned based on a specific capability level, rather than a broad department name. Treating specialized engineers as interchangeable parts based on their job titles creates a false forecast. It introduces a rounding error that quietly compounds with every task you schedule. Every complex project schedule actually contains 2 distinct critical paths running simultaneously, but most planners are only tracking one of them. The visible task critical path dictates the longest chain of dependent work. Underneath is the hidden resource critical path, bottlenecked by a single scarce skill. Ignoring this forecasts an unstaffable project where dependencies align, but human capacity violently overlaps. The common instinct when this bottleneck becomes obvious is to throw more people at the delayed task. But adding headcount without adding the specific required skill actually slows the project down. It introduces massive coordination overhead before it yields any extra throughput. There is a severe substitution cost. When an unqualified person steps into a specialized role, you lose time to rework, slower velocity, and inevitable errors. True capacity is not headcount. It is strictly skill-matched capacity. If you have to substitute a less qualified resource, the ramp-up penalty must be explicitly priced into your schedule. There is an operational belief that booking every available hour, aiming for 100% utilization, is the ultimate goal of resource planning. But queuing theory proves that maximizing a specialist's time is actively detrimental to project velocity.
Look at this chart plotting utilization against cycle time. As a specialist's utilization crosses the 85% threshold, small delays begin to compound uncontrollably. The cycle time violently spikes. The operational reality of this spike is severe. Cycle times routinely increase by 3 to 4 times their normal length because a backlog of interruptions forms with nowhere to go. An expert scheduled at maximum capacity has zero headroom. They cannot absorb unplanned requests, support tickets, or standard project friction. A fully utilized specialist is not a sign of efficiency. They are a critical point of failure waiting for a single interruption to halt the entire chain of work. Deliberately scheduling headroom for your most constrained specialists is a mathematical necessity to maintain velocity. Let's look at how this breaks down in production. Take the case of Talus Ridge Engineering. They scheduled a 14-week control system upgrade across 3 manufacturing plants. On paper, the resourcing plan was airtight, with 5 available controls engineers. But the calendar missed a critical variable. Only 1 of those 5 engineers possessed certified experience with the specific legacy PLC platform. The other 4 engineers were highly capable, but they were on an entirely different skill track. They were controls engineers by title only. By week 6 of the project, this hidden mismatch created a massive backlog. That single expert was double and triple booked across the plants, trying to handle the specialized work. Meanwhile, the 4 available team members sat blocked, stuck on tasks they couldn't actually complete. The schedule was built exactly by the book, but broken by the calendar. On the screen, the project status showed green. In reality, they were 6 weeks behind. To solve the calendar fallacy, you have to build schedules around true skill depth. This requires a 5-stage method known as the match model. Step 1. Map. Translate every task into a specific required skill. Step 2. Audit. Calculate true availability by subtracting meetings and context-switching tasks from nominal hours. Step 3. Test. Classify personnel as novice, practitioner, or expert for the demanded skill. Step 4 is calibrate. You let the scarcest matched skill, not the standard task dependencies, set the overarching pace of your sequence. The intent of this framework is to flip the traditional order of operations. You let known skill constraints shape the sequence from day one, rather than discovering them as risks a month into production. Talus Ridge applied this exact model retroactively to save their failing controls upgrade. Instead of running the plant upgrades in false parallel, they resequenced the work, serializing the legacy platform tasks against their one true expert. They also paired a practitioner with that expert for 8 weeks. They stopped treating cross-training as a background hope and scheduled it as a dedicated task to build a second qualified resource. Finally, they executed the H in the match model, hold. They placed a strict schedule buffer exclusively around the legacy platform bottlenecks, rather than spreading safety margins evenly across the entire plan. The intervention worked. The firm recovered 4 of the 6 lost weeks and permanently eliminated their single point of failure before go-live. Project managers can sequence the work, but they must co-own the skill matrix with the functional team leads. Only the leads actually know the technical depth of their people. If the schedule survives without knowing who is actually capable of executing the work, it was never a schedule. It was a calendar with ambitions.